Great morning, mini mathematicians. Thanks for working hard on 5.1c and finishing that up. Now let's make sure we're writing in our notebook entry for 5.1d, negative exponents in the power of 0 on Desmos. Our lesson purpose is we're going to add on to our exponent rules how to simplify negative exponents and 0 exponents. And the 0 exponent expressions are not simplified if there are negative exponents, and we're going to explore what 0 to the 0 is. So hopefully those two videos you just watched from Khan Academy kind of shedded some light on how we simplify negative exponents. And you're going to be working on this Desmos lesson in your groups together. And we will check back in and go over the last couple slides in about 30 minutes. So thank you for working together. Stay on the same slide as your group, and we will see you in about 30 minutes. Please pause the video now. Okay, as promised, I'm going to be going over a couple of slides from this lesson, 5.1d, slide 30 to the end, 35. So taking a look at slide 30 with me, here we see we have 3 squared to the negative first, n to the negative second, 3 to the negative third, and n to the third. Something you could do right away is you could make all of these exponents positive by bringing down that whole power. If it's in the numerator, bring it to the denominator. If it's in the denominator, bring it to the numerator. When the power crosses the line, we change the sign. So 3 squared to the negative first is going to come to my denominator, and the exponent will become positive. N to the negative second will come to the denominator, and the exponent will become positive. N to the third will stay in my denominator because it's positive, doesn't need to change. And 3 to the negative third will come to the numerator and become positive. From here now we can add these exponents because it's a product of powers, and we have a total of n to the fifth. And here, this is 3 to the second, and this is 3 to the third. You might think about simplifying, but we can use our exponent properties here as well and say there's going to be 2 factors of 3 and 3 factors of 3, so we'll end up with 1 factor 3 in our numerator. And there's our answer for slide 30. Moving on to slide 31, again, I'm going to make all of my negative exponents positive by crossing the line and changing the sign. So I'll have a squared, b to the first, b to the fourth will come to my numerator. In my denominator, I'll have a cubed. There's no b values, but there is now c to the third. From here, I'm going to use my quotient of powers and my product of powers rules. And 3 factors of a and 2 factors of a. 2 factors will cancel out. There'll be 1 factor left in the denominator. There will be 5 factors of b in the numerator, and c to the third power will stay in the denominator. Excellent. Taking a look on to slide 32. Here, I'm going to take all my negative exponents, almost all of them, and make them positive, except right here I'm going to use my power of a power and multiply. So this ends up being -1 times -2 actually gets you +2. So I can actually leave that 2 squared there. So from here, separate my numerator and denominator. T to the third will come into my numerator. All of these are going to come to my denominator, and nothing else has a negative exponent. So all of this is going to come to my denominator. I'll write what's already down there. 2 squared. There's a k. There's also now a k to the third. There's a t to the fifth, and a 10 to the first. Remember, when you cross the line, you change the sign just of your exponent. Here, these k's, those exponents can be added, and these t's, we're going to have 3 factors cancel out, and 2 factors of t will be left in the denominator. So now let's see, we have 1, 4, 2 to the second times 10, k to the fourth, t to the second, and we can keep simplifying this. 140 k to the fourth t to the second. And that's your final answer for slide 32. Perfect. Moving on to slide 33. Taking a look at slide 33, we notice that there's two ways to do these problems. If you wanted to make the exponent positive on the outside, we can take the reciprocal of everything on the inside. So let's do this problem two ways. The first way is to make the exponent on the outside positive by saying that this is take the reciprocal of everything on the inside and then make the exponent positive. From here, I notice that this is one giant fraction bar. This x and this x cancel out to make 1. 4 and 2 cancel out to make 2, so I really just have 2 squared, which is 4. Excellent job. And then if we wanted to look at this another way, we could do power of a quotient and say this is x to the negative second, 2 to the negative second, 4 to the negative second, and x to the negative second. And then decide to cross the line and change the sign. 4 squared x to the second, x to the second, 2 squared. If we wanted to, we could rewrite 4 as 2 squared. So we see that this is 2 to the fourth and this is 2 squared. These cancel out to make 1, and you actually end up with, again, 2 squared, which is just 4. So two ways to do the same problem. Let's move on, looking at slide 34. These are exponents. I know it almost looks like they are just being multiplied by, but they're actually exponents. You can see they're kind of floating. So thinking about this, we could do power to a power and simplify this first. So let's see, that would be x to the 2 times the quantity of n minus 4 is 2n minus 8. All over x cubed times the quantity of n plus 1 gets me x to the 3n plus 3. So let's think, oops, sorry, I have to move that up. Let's think about which exponent is larger. A number times 3 and adding 3, or that same number just times 2 and then subtracting 8. Obviously this denominator is larger, so I'm going to think about when all the factors cancel out, I will have leftovers in my denominator. And also from here, I'm going to think about taking the larger one, 3n plus 3, and subtracting the quantity of 2n minus 8. If I distribute that negative, I get 3n minus 2n plus 3 plus 8. 4, once we simplify our final answer of 1 over x to the 3n minus 2n is 1n, and 3 plus 8 is 11. There's your final answer for slide 34. Perfect. The last problem, slide 35. Here I know b to the 0 is just 1. And then I'm going to bring my negative exponent up to make that positive. A to the 3n over a to the 7n. B to the first is in the numerator now. From here, even if you didn't want to think about 7n being greater than 3n, we could say, okay, 3n minus 7n, that's going to get you negative 4n, b to the first, and now I know I can't leave a negative exponent, so you could cross the line and change the sign. Oops, positive 4n. So your final answer is b over a to the 4n power. So now what's kind of nice is now that you know how to deal with negative exponents, you don't have to worry about if you accidentally did 7n minus 3n or 3n minus 7n. Awesome. Thanks, mini mathematicians. Hope you had a great day. You have reflection number 4 for this lesson. Enjoy, and I will see you next time. Thank you.